Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have a to the power of b minus b to the power of a equals to 17, and we solve this problem for the values of a and b. So here the very first step we are going to do is here first we multiply and divide the exponents of both of these terms by 2, and we write it as a to the power of b and its whole power 2 over 2 minus b to the power of a and its whole power 2 over 2 equals to 17. And after that we use here the nice exponential law, and you very well know about this law. If we have a to the power of m to the power of n, it will be written as a to the power of m times of n. So now we use this nice exponential law on both of these terms, and these terms is written as a to the power of b over 2. Here we multiply this 1 over 2 to this exponent, and it will becomes b over 2, and it is a to the power of b over 2 and its whole square minus b to the power of a over 2 and its whole square equals to 17. And now in the next step we convert this nice exponential equation into the algebraic form, so that here we will just take x equals to a to the power of b over 2, and we will take y equals to b to the power of a over 2. So here we substitute these two values to the above equation, and our above equation will becomes in this form. So we put this value equals to x, so it will becomes x square, minus we put this value equals to y, so it will becomes y square, and this whole equals to 17. And now you see here it will becomes a nice algebraic identity, and we know that x square minus y square equals to x minus y times of x plus y equals to 17. So here you focus on the left hand side, and you see that we have two factors are multiplied by each other in the left hand side, so that we convert our right hand side to the product of two factors. So we make the factors of 17, and here we have two possibilities in which we get 17. And the first possibility is 1 time of 17 equals to 17, and 17 times of 1 is also 17. But if you focus on these factors and we make the relation between these two factors, and we say that x minus y is always less than x plus y, so we choose those pair in which the first pair is lesser than the second pair, so it should be 1 is less than 17, so this is whole. And if you focus on this, so 17 is greater than 1, so it cannot be whole. So we choose the first pair, and now we compare the left hand side with first pair of values. So after comparing the left hand side to these pairs, we get the values here x minus y equals to 1, and we get x plus y equals to 17. So we have two equations here, so we call this as equation number 1, and we call this as equation number 2. So now we make we solve these two equations, and here first we find the values of x and y, so that if we add equation number 1 and equation number 2, so you see here this is negative and positive y are gone, and we add x by x, and we get 2 times of x equals to, in the right hand side we have 1 plus 17 equals to 18. So this equation implies that our x equals to 18 divided by 2, so we get the value of x equals to 9. And similarly we focus on to find the value of y, so that we subtract equation number 1 and equation number 2. So now we subtract these two equations. So when we subtract these two equations, it means that we change the signs. So when we change the signs of x and y, so we cancelled the x values, sorry, this is negative term, because now we subtract these two. First we add, and now we subtract. So here I can write these two equations. So we have x plus y equals to 17. This is first equation, and x minus y equals to 1. This is second equation. So because we subtract these two values, so it will becomes in this form. So these are gone, and here we add y plus y equals to 2y, and 17 minus 1 equals to 16. So this implies that we have the value of y equals to 8, because 2 8s are 16. So we easily get the values of x and y. And now here we write both of the values. So for the value of x is 9 and the value of y is 8. So now we back substitute the values of x and y, and you see here we have our x equals to a to the power of b over 2, and we have y equals to b to the power of a over 2. So we substitute these two values here, and we get its output in this form. So we have a to the power of b over 2 equals to 9, and our y equals to b to the power of a over 2 equals to 8. So now in the next step, we make the factors of 9, and we write it as in this form. So here first we remove this 2, and we write it as, so that in order to remove this 2 we need to make the uh, square on both of the sides, so that it will becomes a to the power of b equals to 9 square. Because if you take the square on the left hand side, so these 2 and square are gone. And similarly here we get a to the power of b equals to the square of 9 equals to 81. Similarly, we take the square on this term on both of the sides, and we get b to the power of 8 equals b to the power of a equals to 8 square, and we have b to the power of a equals to 64. And now in the next step we write this 81 as, so we make the factors of 81, and we know that the factors of 81 are 3 to the power of 4. And similarly we compare both of the sides. So we equate the base and exponents, and we have our base is a equals to 3 and exponent is b equals to 4. So these are the first solutions of the given equation. And now we solve the second case. So in this case we make the factors of 64, and we know that the factors of 64 are 4 to the power of 3, and we write it as b to the power of a equals to 4 to the power of 3. And now we compare both of the sides, and we compare base and exponents. So when we compare base, we get the value of b equals to 4, and when we compare exponents, we get the value of a equals to 3. So this and this are the same solutions. So this is the final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.